the rate constant K times A times B. Okay, so it's X and Y. So let's see. According to our data table, the concentration of A in experiment 2 is 1. The concentration of B in experiment 2 was, let's see, 2. And then we'll do the same thing in the denominator, so K times C. So for reactant A in experiment 1, the concentration was 1. And for reactant B, the concentration was 1 in experiment 1. And then for the rate, let's see, so for experiment 2, the rate was 20. And then for experiment 1, it was 10. Okay, so let's do a little bit of math here. So 20 divided by 10 is 2, so we have 2. Can we simplify the right side of our equation? Yeah, so we can get rid of the k's, right? Yeah, let's get rid of these. So then 1 to the x power divided by 1 to the x power. Yeah, this cancels each other out. Okay, so we can get rid of those. So now we have 2 to the y power divided by 1 to the y power. We can write this equation or this side equation as 2 to the, yeah, this is the same as 2 to the y power. So now we have 2 is equal to 2 to the y power. So if we solve for y is equal to 1. Okay, so based on these experiments, this tells us that the order of the reaction with respect to reactant B is 1. So that tells us that if we double the concentration of B, that should double the reaction rate. So again, that's what the order of the reaction tells us. It tells us what happens to the rate if we change the concentration of that reactant. Okay, so what I'd like you to do is to compare two of those experiments to try to figure out what X is. Okay, so to figure out X, which experiments do you want to compare?
1 and 3.
Okay, so let's compare experiments 1 and 3. So let's make some changes here. So let's see, if we make this one, we erase these numbers here. So let's start this one again. Okay, so I've heard from students, not in this class yet, but I've heard from students in the past that you like these fill in the blank questions. So here are the blanks. So what goes in this blank here? 10. What goes in this blank? 2. And what on this blank?
1.
And how here?
1.
Okay, so we have 1 is equal to, let's see, we cancel these out. Let's see, so we have 2 to the x over 1 to the x. That's the same as 2 to the x. So we have 1 is equal to 2 to the x power. So if we solve for x equals, yes, we solve for x equals 0. So that means that if you change the concentration of reactant A, it doesn't affect the rate. Okay, so here we have, if we plug in our numbers here, so x is going to equal, let's see, we said that x equals 0, and y equals 1, so this implies that k times b. So this is our rate law. The rate is equal to rate constant k times concentration of b to the first power. Based on this information here, can you calculate the rate constant k? So how would you calculate k? Okay, so we have our rate law. Rate is equal to k times b. We know what rate is. Do we know what b is? Can we solve for k? Yes, let's do that. Does it matter which experiment we use?
No.
So we should get the same answer, shouldn't we, for each experiment? Yes, let's do that. So we have, let's see, k is equal to the rate divided by b. So in this case, it would be 10 divided by 1. So this should be 10. We haven't looked at units yet. We'll take a look at units in a minute. So for experiment 2, let's see, we have rate is 20 divided by 10. That should be 10. And for experiment 3, 10 divided by 1 is 10. So yeah, so we should get the same number each time. Okay, so this shows that the rate constant should be a constant that as long as we use the same temperature. Okay, so again, rate constant is a constant at the same temperature. If we change the temperature, the rate constant is going to change. Okay. Okay, so before we do one of these problems from the textbook, let's answer this question. So a reaction is first order in reactant A. If we if we double the concentration, what's going to happen to the rate? Is it going to stay the same? Is it going to double? Is it going to triple? Is it going to quadruple? Okay, so another way of stating this question is, okay, so for question C, it says we have some rate, and it says it's first order, we're in reactant A, so rate is equal to k times A to the first power. So if we double the concentration of A, what happens to the rate? Is it going to stay the same, double, triple, quadruple, or other? Okay, so again, if we double the concentration in A, what happens to the rate? It should double. If we triple the concentration in A, this should triple. Okay, for part D, a reaction is first order reaction in reactant A. If the concentration doubles, gosh, isn't that the same question? That's the same question. What did the Let's go to question E. If A reaction is second order reactant A. So now let's change this exponent from 1 to 2. If the concentration doubles, what happens to the rate? Yeah, it should go up by a factor of 4. Okay, so in this case here, if this doubles, we have 2 squared or 4, and then the rate's going to quadruple. Go by a factor of 4. Okay, let's do this problem from the textbook. So this is problem 14.15. And that's on page, let's see. That's on page 501. It says, consider the reaction A plus B going to products. From these data obtained at a certain temperature, determine the order of the reaction and calculate the rate constant. Okay, so this is page 501. And this is problem 14.15. So it says you have A plus B going to products. And they show a data table for 3 experiments. So you have, let's see, A. You guys have your books? You don't have to write this on the board. You need to write it on the board?
Yes, please.
Okay, so we have 3 experiments. Let's see, so 45. So what you want to do is determine the order of the reaction and calculate the rate constant K.